Great, great. Today is the third in series of our lectures, and we are still very glad to have on the call today Mr. 𝙑𝙞𝙧𝙩𝙪𝙖𝙡 and Engineer Michael 𝙑𝙑𝙞𝙧𝙩𝙪𝙖𝙡. They will continue with the same topic, gas processing plant operations. And this afternoon, we will start with Albert. Albert is the operations manager for Ghana Gas, and he will take us for 40 minutes. Then Engineer Michael 𝙑𝙑𝙞𝙧𝙩𝙪𝙖𝙡 will come in. We'll also continue on the same tangent like we did yesterday. Albert, please, if you are ready, kindly project your slides and then take over. The rules of engagement still remain same. We will be having questions and answers later after the two lecturers have delivered their keynote addresses. And quickly, we are out of here. So, Albert, please, over to you. Thank you so much.
Good afternoon, everyone. Please, can you hear me? Am I loud and clear?
Yes, please. You are loud and clear.
Thank you very much for affording us the audience once again to share what we have with the team and also give us the opportunity as well. And also give us the opportunity as well to learn. Hello, Mr. Moderator.
Yeah, sorry.
We can hear you speaking. We can hear you speaking lovely airway. So if you could mute your mic the next time. I was just saying that thanks for the opportunity for us to share with the team once again, and also another opportunity for us as well to learn from everyone here. It's an honor always to be assistant with anything to do with SPE. So what we will do today is that we will go back and just do a little recap from the first couple of slides, and then we'll delve into what we are going to discuss today. My name is 𝙑𝙞𝙧𝙩𝙪𝙖𝙡. I'm part of the operations team. I'm part of the operations management team. I am responsible for the lab operations within the plant, and I have my colleague, Engineer Michael 𝙑𝙑𝙧𝙩𝙪𝙖𝙡, as well, who is part of the operations management team, who did a sterling job yesterday. So I hope that I'll be able to follow his lead. As we said, it is a bit frozen now. I don't know. Michael, sorry. Mine is, okay, thanks. It's moved on. This slide yesterday, we spoke about our vision and the mission for Ghana Gas. Is, as we said, to be a trusted, reliable gas services company. We are the only one that currently processes natural gas in the country. And we know that the country is heavily dependent on natural gas being used for power generation for Ghana, as well as power generation for some of the tiles and ceramics company. Our mission is to contribute towards the economic development by operating our infrastructure in a safe and cost-effective and reliable manner. The gas infrastructure operations, basically, it's about having built a brand new infrastructure in the nation since we are the first of its kind and there hasn't been any after us. So it was incumbent on us to build an infrastructure from offshore, that means on the sea to land, and also underground, under some few rivers. We got our first gas from the FPSO Kwame Nkrumah in November 2014 through 58 shore all the way to our gas processing plant, which we call the GPP. So when I use GPP, what we mean is that it's built an onshore pipeline, which is a 20-inch pipeline from Atwabo to Aboise in the western region and Takoradi close to Shama. That's a 110-kilometer, 20-inch pipeline, which goes under 3 riverbeds, and it also goes through some Galamsey and mining areas as well. Now, this is the overview of the gas processing plant, a pictorial bird's eye overview of the gas processing plant. We get gas, raw gas, or as we call it, wet gas, from offshore, from the FPSOs. It could be from Atamils, or it could be from Kwame Nkrumah, and it could be from both. We will get raw gas that will come into the plant. The raw gas will then be processed. After we process the raw gas, we will get 4 products from it. The 4 products that we will get is what we call the lean gas. The lean gas, we also call it the dry gas, or we have another name for the lean gas as well, which we call the sales gas, SALES. So for the same product, we have 3 names for it, either dry gas, lean gas, or sales gas. The raw gas that we get is also known as wet gas. So effectively, we strip the liquid from the raw gas and we get the dry gas. After we have stripped the liquid hydrocarbon liquid, we will then process this hydrocarbon liquid to get our other products, which will be the liquefied petroleum gas, which is the LPG that we also call the cooking gas. And then after that, we will get condensate, which is similar to petrol, but it doesn't have the same specification of petrol. It has got an inferior specification to petrol. So what the off-takers, our clients, will do is that they will come in and buy this condensate, and they will take it to Tema Oil Refinery, and they would upgrade this condensate for either premix or for petrol for general use in the market. So we are aware that we will get raw gas, we will process it, we'll get sales gas, and after we've processed the hydrocarbon liquids, will give us also LPG and also that of condensate. So one feed that is coming in, we render it into 3 products for the market. Now, the gas processing plant is made up of mainly 3 units. That is the laboratory team, the main process plant, and also the utilities side of it. As it is now, I am going to delve into the laboratory issues, then we will lead on to the main process and also that of the utilities side as well. Now, this is just another pictorial view of some of the instruments or the equipment that is used to the laboratory. The laboratory basically is the eye for the firm. Our lifeline is dependent on the quality of the feedstock that comes in. When we don't know the quality, we cannot also work out our economics. So it is very, very important that the lab acts as the eye for plant operations, and it feeds into also our financial statement as well. Now, the lab activities is made up of sampling of the gas that comes in, as well as analyzing it, and also analysis, sampling and analysis of the products that we will sell on the market. The role of the lab is to ensure that we are giving out quality products. We will constantly be performing routine tests, which aids with monitoring of the quality, and also they are involved in troubleshooting activities, which enables us to check the performance of the different units that we have in, which I'm sure along the line, Michael will go on to explain about the ethanizers, the towers that we have in, the different separators that we have in stock, because we do have sampling units along the lines that we can take products from there and analyze it to ensure that the parameter changes that have been made, either temperature change or pressure change, is actually having the right effect to produce the product within the specifications of the nation or the specifications that we have given to our client, where we have financial, legal, and moral obligations to them as well. So, as we've spoken about the lab role, we are compelled to sample periodically the gases, like the raw gas and the source gas and the fuel gas. The fuel gas is the gas that we use to power our plants. So the gas that comes in that we will normally sell to VRA, for them to produce electricity, we use some of this gas as well to power our plant. We do have gas generators in-house, so we are pretty much self-reliant. It will later on about that our self-reliance is not just only on our electricity, but even when it comes to water usage in the plant, we have got wells in the plant that we rely on our own water supply for our toilets and other facilities as well. So we are pretty much self-reliant. It's interesting that the plant was built in Western region and Kwame Nkrumah came from this side and effectively promoted self-reliance. This is what the gas processing plant as well we do. We are self-reliant on our facilities. We generate our own electricity in-house, and also we produce our own water in-house. The very last option will be for us to go on the national grid, but we produce our own electricity to use for the activities in the plant. So typically, the gas that comes in as a raw gas is made up of mainly hydrocarbon components, which is the methane, the ethanes, the propanes, the butanes, and the pentanes and the hexanes. Once we move from the propane onwards, once we get into the butane spheres, we start having isomers. So we end up having normal butane, and isobutane. Then we move on into the isopentanes and the normal pentanes and the isohexanes, all to the octanes and the nonanes. Basically, down the chain, we do have the single chains of isomers within it. Now, as I made mention earlier, the gas that we get is our lifeline. So it is important that we use the right techniques to analyze it, to ensure that the physical properties of this gas analysis is what we will then convert to sell as the heating value. Because our gas, the lean gas that we sell to our off-takers, they are charged based on the heating values that is given to them. So those will be some of the physical properties that after we analyze the gas, which we will use like the GC, which is the gas chromatograph, which I shall speak about later, to analyze the makeup of the gas. Then we will then use the physical constants to calculate the heating values, the Wobbe index, as well as the molecular weight and the viscosity and so many other different physical properties. In the same vein, after we have processed the raw gas that comes in and we've stripped off and processed the source gas, we will then have what we call the liquefied petroleum gas, which is the LPG, which is the cooking gas, as we say, or in the houses, we just say gas. When we're talking about cooking gas, it's LPG that we are referring to. Also, we have to analyze it according to the standard. And the standards that we have been using is the standards from the Ghana Standards Authority, which works with the National Petroleum Authority, and it has got stakeholders as ourselves, as well as the TOS and other stakeholders. We are all involved in the development of these standards. And Ghana Gas, myself and Michael, as well as some of the other colleagues, we are part of the technical team that contributes towards the standards development when it comes to the gas and the petroleum side. We are part of the technical team that contributes to the standards development. So typically, our LPG from Atuabo will be very different from the LPG that will be imported into the country. I shall go on to talk about that specifications as part of this presentation. So when we analyze the LPG as well, which is very similar to the way that we analyze the gases, be it raw gas or the source gas, we use the gas chromatograph to analyze it. We will then know the DNA of the LPG, and then we will then be able to calculate the vapor pressure and the density from the mole fractions of the LPG. But also we do have equipment as well that we can do the physical determination of the vapor pressure and the density. However, when it comes to the corrosive properties of the LPG, we don't do it from the hydrocarbon mole ratios. We do have equipment that we use to analyze other properties such as the corrosion, the mercaptans, and the hydrogen sulfide, which might be or might not be in the LPG. Then we move on to the sampling and analysis of the condensate as well. As I made mention earlier, condensate is similar to petrol. However, the specifications of condensate does not match up to that of petrol or gasoline. It is inferior. In Ghana, normally we sell petrol, that what we call the regular petrol that we buy to put in our cars. It's what we use normally the RON 90, which is research obtained number of 91, RON 91. That is the regular petrol. When it comes to premium petrol, we are using RON 95. However, our condensate that we produce as a result of the raw gas that we get and process, the RON is around 67, between 67 and 72. So as you can see, there is almost about, what you call a 25% drop in the RON figure. So our clients, what they have to do is that they have to buy this condensate and they have to take it to Thermal Oil Refinery for them to upgrade it to become gasoline, petrol, regular petrol, or for Thermal Oil Refinery to upgrade it to become premix, which our fisher folks use to go fishing, to use to power their Yamaha outboard motors to go fishing. Also, we have to ensure that the quality is on point. So we can also look at the physical properties, such as the vapor pressure, the color, the density, the corrosion, as well, to ensure that what we have agreed with the client, it meets its specifications. So we cannot issue a product out without meeting standards, because as I made mention earlier, products that we issue out has got financial and legal implications. So we have to adhere to certain standards. Now, when it comes to standards development, Ghana Standards Authority relies on some of the best standards that are already out. Sometimes you don't have to reinvent the wheel. So in the petroleum sector, these are some of the main standards this. The Gas Processors Association, the GPA standards, which of course, as part of your studies, you have come across the Universal Oil Product standards as well are part of their standards from this for the petroleum sector, as well as certain other standards to ensure that they delve into the appropriate standards. So these are mainly the standards that we use in the petroleum sector. However, within Ghana Gas, we are pretty reliant on the Gas Processors Association standards and also the ASTM standards for our operations. So, you know that we get raw gas, we process this raw gas, and we will get three main products. The three main products that we will get will be the sales gas, which 24 hours a day, we get the raw gas from the FPSOs. 24 hours a day, we process this raw gas. We do not store any raw gas whatsoever. 24 hours a day, we transport this raw gas to the power generator. So when I use VRA as one of them, or car power, 24 hours a day, we are sending them gas. So what we get, we do not store gas. I feel that I have to be pretty explicit here, because yesterday, as part of the questions, we realized that some hadn't understood. So gas that we get from the FPSO, we will process this gas, and all that gas will then be sent to the power generators, be it VRA, and we take a small amount of this gas and we use it to process for our gas generators to generate electricity for our internal use within the gas plant. So after we have sent the source gas, we further process the hydrocarbon liquid that we get, and we will get LPG from it. And then after we get the LPG we store it in-house until we send it to our off-taker, who will sell it to the market. Our off-taker being Quantum Terminals Limited. And then also we will store the condensate, which I said is similar to petrol. We store it and later sell it to the off-takers. So the only products that we store is the LPG and the condensate. Whereas the lean gas or the sales gas or the dry gas, all is sent to VRA or the other off-takers for power generation. I feel that I have to explain a bit more about the LPG because obviously the gas doesn't come to our houses. It comes to our house after it has been transformed for power generation. So we don't get to have a hold of that. The condensate as well is an intermediate product. So we don't get to have a hold on that. However, it's the LPG that we are more likely to have it in our house or in our houses or in our place of abode. So I feel that I will give you an overview of the LPG that we produce at the Atuabo gas plant. Now, the lab analyst, which is made up not solely of those from a chemistry background or biology or laboratory background, as part of our lab analysts that we have here, some are from chemical engineering, mechanical, petrochemical. So we've got a diverse group of engineers or technical people who are involved with the lab function. And the petroleum side, as well as the chem and the biologists and all the different technical disciplines are involved with the role of lab analyst. The lab analyst will be running periodic sampling. That is, they will go and take a sample, come into the lab to analyze, to look for all the different chemical properties, as well as the other physical properties, and then will advise the central control room engineers about the states or about the specification of the product analysis that they have done. When they find something that is out of range, they will advise the process control room engineers, and the process control room engineers will make a tweak. Either they will change a temperature or pressure, or they will change both to ensure that we end up getting the product specifications right. So the lab team ensures that the product, the LPG that will be put on the market, as well as the condensate that will be put on the market, and also the sales gas, all of them meet the specifications as has been agreed by the standards or by the off-takers. So we strictly adhere to the standards from the Ghana Standards Authority standard, which has been developed by all the stakeholders, with our regulator, National Petroleum Authority, NPA, playing a major role in the standards development as well. We cannot do analysis without adhering to SOPs. It is important that we adhere strictly to the SOPs in-house, because if there is a legal issue, it is these SOPs and these standards that will be used to ascertain whether the product, as we set the specifications, are what we said they are. So they can give it to a third-party laboratory, then tell them, the third-party laboratory, that this is the standard that was used for analysis of this particular product. So then they would have to then do the same and then compare it with our results. So that is the bit that we speak about, that we've got financial and legal as well as moral implications, which enables us to ensure that the quality of the product, the integrity, is also on point as we have agreed on. Now, the main instrument within the laboratory that we use for analyzing the gas or the LPG or the condensate is what we call the gas chromatograph. The gas chromatograph, when you run samples within it, it churns out or it gives out the footprint of the hydrocarbon makeup of that particular product that you are analyzing. So on the left is a typical tabletop gas chromatograph. This gas chromatograph on the left will be used to analyze, it can have dual function. It will be used to analyze the gases, be it raw gas or sales gas, and it can also be used to analyze the LPG, the liquefied petroleum gas, which is another gas as well. It has got different detectors on that will then churn out the results for you. So you take the sample, you connect it, the sample will then be injected into it. It would have columns within it that enables separation. Then later, the detectors that are present will then identify and give the molecular breakdown, the mole fraction breakdown of all the hydrocarbon components that are present within it. On the right-hand side, it's the same gas chromatograph. However, this has got an automatic sampler on top. That is the vertical, as you can see, there's a vertical component on it. This deals with liquid products. So if you were to bring in a diesel or gasoline or kerosene for us to analyze, this will be the type of gas chromatograph as well that they will use to analyze in the laboratory. This is the benchtop one. Now, it will interest you to know as well as that on the sales gas pipeline, we also have an automatic gas chromatograph on it. Now, this automatic gas chromatograph, what it does is that every 3 minutes, it will take a sample of the sales gas and it will analyze it and it will give the results out on a SCADA system, which later on it is used to bill the clients. As I made mention earlier, that we will bill the clients based on the heating value that we have agreed to sell to them, as well as the volume of gas that they would have consumed. So this mainly in the lab is the heart of the lab. If any equipment were to break down, we do not want these ones to break down because this is where we determine the quality of the product, the main quality of the product, the makeup of the gas, as well as the makeup of the LPG, which will inform the CCR team to make the necessary parameter changes. So, as I was saying, the gas chromatograph comes in different models. This is the benchtop one, and there is also the online one, which is very, very different from this. Now, if you were to see the gas chromatograph, it has also, this one has specially been configured to analyze that of our products. But you could go to some hospital or you could go to different places and you see a gas chromatograph there. However, it will be similar to this, but it doesn't mean that it will do the job that this one does. It could be used for analyzing, let's say, drug in someone's blood, or let's say marijuana in someone's blood. Can the gas chromatograph allied with what you call a mass spectroscopy can be used to make those analyses? But in our case, since we are pretty much dependent on hydrocarbon makeup, this gas chromatograph has specifically been designed solely for the analysis of the hydrocarbons that we process in-house. So, as I made mention, I feel that we just have to delve into the LPG side. We will use the gas chromatograph for LPG analysis. When it comes to LPG analysis, we are basically reliant on the ASTM 2163 or the GS D2163. As you can see, the ASTM is the American standard and the GS is the Ghana standard. But as you can see from the end, the standards are almost the same. So 2163, if you were to look for GS D2163 and you cannot find it, if you look for ASTM D2163, you'll be able more likely to come across it you will know that it's the same as what will be in the Ghana Standards Authority one. Fortunately for us, we do get, yesterday we made mention that we get what we call the sweet gas. Our gas has got negligible quantities of sulfur within it. However, it doesn't stop us from analyzing the sulfur that is present within LPG. And some of the other sulfur compounds that will be present within LPG will be the mercaptan. Yesterday, I made mention that that has got a foul smell. It's like a rotten egg smell. So that is what helps one to know when there is a gas leakage. When you switch on your cooking gas and you can smell it, the smell is from the mercaptan. It's the sulfur compound that is present within the LPG, which is the mercaptan. We also have other hydrocarbon, hydrogen sulfide as well will be other sulfur compounds that can be present in, and sulfur dioxide and sulfur monoxide can be. However, the sulfur components, we cannot have too much present in because it does have corrosive properties. So we also have to analyze for corrosion so that it will help one know about the integrity and the quality of the gas so that it doesn't have too much effect on your gas cylinders as well. Because too much presence of mercaptan or other sulfur components present in will eventually lead to pitting within your cylinders, and it will lead to corrosion as well. Another property as well that we deal with will be the 95% volume evaporated. That gives us an idea of how stable that LPG product is. And also we have to analyze for residual matter to show the cleanliness of the LPG and oil stain as well. Now, we know that the compositional makeup of the LPG will be what will contribute to determining the properties of that LPG or that product. And as I made mention earlier, normally we will use the gas chromatograph to analyze for the composition makeup of it. After we know the hydrocarbon breakdown of the LPG, our LPG mainly is made up of propanes and butanes. However, there are minor components of ethane present in and minor components of some pentanes and hexanes present in, but mainly it is made up of propanes and butanes. Once we know the makeup of it, let's say there's 49% more percent of butane in, 50 more percent of propane in the LPG, we can use it to calculate the density, and also we can use it to calculate the vapor pressure from the hydrocarbon makeup. Further on, we can also physically analyze the vapor pressure and the density without resulting to calculating it. And then we also analyze the corrosion as I made mention earlier, as well as the sulfur and the mercaptans that are present within the LPG. Here is a typical specifications for the LPG in Ghana. The red side, as you can see from column 1 to 11, is by Ghana Standards Authority D2163, which is the same as ASTM D2163. This analysis is obtained from the gas chromatograph. So as you can see, it gives out all the analysis for the hydrocarbon components that will be present within the LPG. Then we move on to the vapor pressure, which I said earlier that we can do by calculation. Total sulfur component, as well as corrosion and hydrogen sulfide and mercaptan are all done with different lab instruments. And then the vapor. So once you pick up LPG certificate, this is an agreement with the Ghana Standards Authority as well as the NPA and the other stakeholders that this is the way that we have to report our LPG specifications. So once NPA picks up a certificate for LPG, either from Atwabo or from another third party, when they look at column line 6, they will expect to see that line 6 is made up of N-butane. It could have come, the LPG could have come from Tech, it could have come from Legon, it could have come from UNE, it could have come from any other university being sold in the market, this is how they would expect your certificate of analysis to be presented like. So, as we made mention, the LPG and the products that we have here determines our lifeline. It is important for the laboratory team to follow different processes, follow the standards, operate SOPs, follow the standards that have been set out there to ensure that we become the eyes, not only for the CCR, because that is also what we use to make money for the company. As I've dealt now with the lab side, we will then delve into the main process side, and I would ask my colleague Michael to take over. Thank you very much. Michael.
Thank you so much, Albert. I think Michael will just take right from here, right?
Yes, I will.
Okay,
Yes,
all right. Please, over to you. Thank you so much.
Okay, thank you very much. It's James, right?
This is Philip. This is Philip Banini.
Okay,
Yes,
thank you very
yes.
much, Philip. So, once again, we are very, very privileged to be able to discuss the key things that happens at the gas processing plant to everybody. We always use this opportunity to let you know that the gas processing plant is your money, is your taxpayers' money that has made this possible. And it's something that we all should be proud of. It's something that generates the key fuel within the plant for within the country for as part of the power generation and energy mix. Okay. When I do these presentations, I really love it when it's interactive. But unfortunately, the way we have set up the webinar, we are not able to do that. So maybe when it gets to questions and answers this time around, I'll be asking more questions so that people can answer.
All right, that's fine.
Because then it means that you know that whatever you are saying,
it gets
understood, gets understood, and a better feedback comes from.
Yeah, okay. I agree. I agree.
So we've discussed yesterday about the key units that run through the plant, the main objective of the gas processing plant, and today I'm honing in on the gas processing plant, is to process the raw gas or the dense phase natural gas. Main reasons are to remove water, to remove any impurities, whether solid or liquid, and also to separate the product into their various processes, going through the fractionation stage. So we have talked about it yesterday in kind of a brief, and I'll use this next maybe 10-20 minutes just to hone in for you to appreciate those parts, especially for our petrochemical engineering students, because these are some of the things that, or chemical engineer, process engineers, these are the things that we virtually live on. Okay, so if you go into the main process area, you have your reception facility. Your reception facility is actually part of your inlet filter and separation system, but your reception facility is when the gas enters. So once the gas is entering into the plant, it goes through an area we call 𝙑𝙑𝙑𝙑 initial station. And if Albert, you're still sharing, so can we get a pictorial view? Or should I share so that I can control it from my end? Good. Okay, so where this arrow is, the blue arrow that you can see, that whole area is called the 𝙑𝙑𝙑𝙑 initial station, or the reception facility. And that is where the raw gas enters the plant. It is also where the raw gas, the lean gas, that's the processed gas, leaves the plant. So that's why we actually, when you come into the plant, it's called the initial station. It's the initial point for the raw gas or the dense feed gas coming from the FPSO to enter the plant. And it's also the initial for the process gas, for the lean gas, your ethane and methane, leaving the processing plant and starting its journey to power generation companies, to non-power generation companies, and for various uses that it has. Within that point, we also have something we call a pig receiver. And when we flow through the units, Albert, if we can go to the pictures, maybe I should. Do you like to stop sharing so that I can take over? I think that will be better, and it will help with control.
Okay, I'll do that, Michael. Thank you.
Okay, I think that's good. Okay, good. So please, can you see my screen, everybody?
Yes, we can see your screen.
Okay, so within the Atuabo initial station here, you have what we call a pig receiver. And as process engineers, as petrochemical engineers, we need to understand that. So a pig receiver is a pipeline intelligence gauge, and the receiver is virtually, so there's a launcher normally at one end and a receiver at the other end. And the main purpose of those is for cleaning of the pipelines, whether offshore or onshore, as well as that it is checking the integrity, both internals and externals of the pipeline. So under normal circumstances, you have a pig launch, whether a cleaning pig to clean the entire pipeline offshore, and in this case, or onshore in an onshore pipeline facilities, or you have an intelligent pig put into the pipeline, and then it will take key details like corrosion, terms of how corroded the pipes have been from your baseline survey. Is there any dents? Is there any bends? Is there anything actually externally encroaching the pipe? It will take all those details and you are able to analyze it. And that's a whole different engineering field that a lot of people are into. And out of this country, that is a lot of money being made out of it as well, those guys who are specialized in that section. So the pig launcher, the pig receiver, for our pig launcher for the raw gas, the pigs are launched on the FPSO and we receive them at the gas processing plant. We also have in that Atuabo initial station area, we also have a pig receiver and a pig launcher for the onshore pipeline, which is a 20-inch pipeline, as we discussed yesterday. So we have our offshore pipeline, which is a 12-inch pipeline, our onshore pipeline, which is a 20-inch pipeline. And we have a pig launcher at the Atuabo initial station, which we can also launch to clean the pipeline, to check for its integrity of the pipeline. And also it is received when you go to Takoradi Regulatory and Metering Station or Takoradi Distribution Station now, it is received there. Okay. So after that, so the key main processes happening in the main process area is your inlet separation and your filters. That section is where you want to take your water out. That section is where you want to take your impurities out. Your next section is your gas chilling or your deethanizer system. That is where you are separating your hydrocarbons, your liquid hydrocarbons from your gas hydrocarbons and going through a temperature change, causing those cryogenic effects where you drop your temperature by using the JT valve. I'll explain more. And then the next third section is your fractionation. That's you separating your ethanes and methanes, from ethane and methane as your product, your propane and butane as your condensate, your LPG, and then your condensate subsequently. And then the fourth section is your dehydration process, where we as a company use glycol as our dehydration process. Okay. And this is a block view of it as well. Very similar to what I have discussed. I'll go to the PDFs and then we'll have a look at it into details. So this is a pig receiver. So imagine, yesterday I told you, imagine a molecule of gas or a flow of gas, 100 million standard cubic feet of gas at the moment running through the pipeline from the FPSOs, Kwame Nkrumah, Atta Mills, Jubilee Field, coming to the gas processing plant. What happens is here, when it enters into the plant, it goes through this yellow bits arrow, the raw gas first. And one key thing is metered. So we have an ultrasonic flow meter. And as students, I want you to, I wish you had questions and answers. I'll ask you about what type of flow meters that you can use to measure gas. But one key competent, very reliable flow meter you can use is your ultrasonic flow meter. So ultrasonic flow meter with this one is a clamped on or wrapped on ultrasonic flow meter with your temperature and your pressure settings, trying to help you to calculate the amount, the volume of gas entering into your pump. And please read more about ultrasonic flow meters. It's really, really important. You know how it works, the principles behind ultrasonic flow, and what they are used for in the industry, especially for gas measurements. Okay. Then it will then go through our inlet separators and filters. This is our inlet separators. Our inlet separators, I spoke about this yesterday. As chemical engineers, as engineers, as petroleum engineers, you want to do a design project at school. You want to be able to let your lecturer understand how reliable or how resilient your plant will be. You need to have some form of an N+1 philosophies on your equipment. You need to be able to have one working and one on standby. And you will see that run through most of the processing plant and the facility. So there's two. Normally, the volume, the plant is designed, this plant, the Atwabo gas processing plant, is designed for 150 million standard cubic feet of gas per day. These separators, these two inlet separators are designed to take 75% or 70% of that volume. So meaning that you can run one separator even if you are running 100 million standard cubic feet of gas per day, meaning one is readily available. If you're doing more than 120, you definitely will want to be using the two separators. And it's a three-phase separator. The yellow bits is your, so as soon as it's entering into the separators, the gas is choked. It's a choke valve to choke the gas. The gas is running normally around 130, 140 bar gauge entering into the plant. You choke the gas to about 110 bar gauge in order for you to have some form of pressure drop. From principle, you know from your principles that a pressure drop in this will cause a dropout of your liquids. You cause also a temperature drop, will cause your separation of liquids, gas, and water. And that's exactly what is happening. So using a three-phase separator with your mix extractor and various things to be able to make sure that you are separating those products from each other. So the green bottom, I would have asked somebody, what do you think will be the separation at the bottom for green? And the obvious question is water because that will have the heaviest density. And so water will settle at the bottom. The middle tier will be your liquid hydrocarbon. And your high tier, which is the green, your yellow, will be your gas hydrocarbon, which more or less be methane, anything. Your green, which is your water, is picked at the boot, and then it goes through our utilities area for processing. Your liquids then starts its journey through that tube, and then it ends up at the de-ethanizer for removing all the entrained ethane or all the entrained methane. Your gas, which is your ethane and methane, goes through the filtering processes to remove any entrained hydrocarbons. So this is how then you start separation. So you condition your gas, you start separating it from various processes, and then after that, you move on to getting your fractionation or your chilling processes done after that. Okay. So once you have your separation of your ethane and methane, and then you have your liquid hydrocarbons also going straight from your three-phase separator, moving into your de-ethanizer. I would have asked, oh, what is de-ethanizer? De-ethanizer is removal of any ethane and methane. And this tower, it has trays of around 30 trays, all packed up. 30 trays with caps, helping you have a very good cross-sectional area for you to have a good mass transfer for you to have heat running through, and your heat is being generated by your reboilers at this bottom. This tower, de-ethanizer, works at a pressure of about 31 bar gauge, 33 bar gauge, I should say, just around 33 bar gauge, and temperatures all throughout also just around 33 bar gauge, and you'll be able to separate your any entrained ethane through this tower, and it will normally come at the top. So you have your C1 and your C2s, your ethane and methane, being heated, going through our normal distillation column processes, and then it will then just come through a compressor, scrubber through an overhead compressor, and to be compressed, because that's your ethane and methane that will join your pipeline to go as lean gas. The main, and that's what I said yesterday, and I will reiterate again, the main part of your lean gas, which you receive, which is your lean gases coming through, goes through your Joule-Thomson process here. So once you get to this point, this unit is called a low temperature separator. And this plant is virtually working on your Joule-Thomson principle. At this point, the pressure of your lean gas or your gas is around 100 bar gauge. The JT valve, using Joule-Thomson process, using the cryogenic effect, drops the pressure from 100 bar gauge to around 50 to 51 bar gauge. In doing that, you have a huge temperature drop. You have a temperature drop which will be as low as, so this unit, when you come into the plant, and if it was a plant tour, you will see that most of the manifolds, the entrances to the vessels are icy. The reason why they are icy is within that unit is minus 33 degrees Celsius normal operating pressure, due to the Joule-Thomson effect, due to the cryogenic effects that I know we have all learned within our thermodynamics classes. So this is pure thermodynamics going on here for us to achieve. One key thing I would like to stress here is we have a heat exchanger system, shell and tube heat exchanger. And there's so many types of heat exchangers that are around, which I'm sure you guys have worked on before. But we have a shell and tube heat exchanger, and that is what we are using: convection and conduction, mass transfer, in order to be able to achieve the temperatures and pressures, or specifically the temperatures that we need for the various gas, whether it's the liquid side of the gas or the gas parts, the gas to gas side of the gas, in order to achieve. Under normal circumstances, some plants will have heaters, and they will heat it to a right temperature, and they will have coolers to cool it to the right temperature. We are using a heat exchanger, which is more effective, saves us money in terms of power on that side and duty, and in order for us to work on that. Okay. So once you have done your heat exchanging, once you have done your Joule-Thomson principle, and you have your LTS, your low temperature separator, separating any of your lean gas and methane and ethane, and then also you have your liquid hydrocarbon, any entrained liquid hydrocarbon, go into your de-ethanizer, and then at the bottom of this is one of the key things is your hydration. So within this temperature, chilling, warming, if you do not dose glycol, it is so paramount that you dose some form of adsorption process. And this is done in order to any entrained water, any entrained molecules of water is absorbed. Glycol as a product, as a chemical, has a very high affinity for water. So it will absorb the water. And of course, when it absorbs the water, it will have a higher density. And hence, it will be at the lower bottom of this separator. And that it moves from here then to the glycol regeneration unit. Regeneration only means virtually that it goes through a process where the glycol water is heated, the glycol mixed with water is heated to a temperature over 100 degrees Celsius in order for the water to evaporate, for you to have your lean glycol back again and for it to start the process. And then normally, under normal circumstances, the glycol is sprayed within the heat exchanger. It gives it a bigger cross-sectional area and is sprayed within there. By the time it gets into the LTS, it's settled and it goes back and gradually goes through the process. There's two ways we try and take water out. We take water out mainly through this adsorption using glycol system, or right at the beginning. Imagine a gas is coming into the plant. It has gone past, it's entered into the Atuabo initial station. You have tested. You know very well that this gas contains water levels more than required. Or you are starting the processing plant. You are not 100% sure of the water that is coming in. You will use methanol. So we have methanol tank here. We dose methanol upstream of the choke valve of the separators before the gas is choked, in order to break any entrained water, so that it helps with the separation processes within the inlet separators and breaks it down into your hydrogen and your oxygen using the methanol. But the only problem with it is you are not being able to recover. Compared to glycol, you would use your glycol regeneration to recover. But this time, you have methanol that is not recoverable. So if you're doing a cost-benefit analysis for such an operation plant, you will be rather wanting to use glycol, which you'll be able to fully recover most of it, compared to using methanol on a daily basis, which is not recoverable. So these are some of the project works when you're doing. You have to actually appreciate and understand and be able to convince your lecturer why your processing plant may be better than another person's processing plant. Okay, so we've gone through the unit 10, which is the inlet filters, inlet separators. We've done the gas chilling, de-ethanizing process. We talked about the JT valve. We've talked about the fact that we need to be able to spray glycol for adsorption, and in order to remove water, in order to prevent fouling, and then we'll move on. Now, by this time, you have your ethane and your methanes mostly removed through the low temperature separator, about 70%, and most of it then separated through the de-ethanizer. I said before, and I hope you remember, that the de-ethanizer is working around 33 bar gauge temperature, but the gas leaving onto the onshore pipeline from the JT section is moving at 50 bar 51. How do we get a 50 bar and a 33 bar gauge gas, or lean gas, ethane and methane, to go together? The only way, as Albert said, and I think Dr. Riverson said a few days ago, is to use a compression system. So we have an overhead compressor that compresses the gas coming from the de-ethanizer to meet the 50-51 bar gauge pressure in order for both lean gas, ethane and methane, to join and start its journey through that Twabo initial station on our 20-inch pipeline this time round, and start its journey to our Kabwazi, to our non-power and power generation. Before it goes, paramount, it's metered, and your guess is right. You use an ultrasonic flow meter to do that. So you are done. You have most of your lean gas. It forms about 80 to 85% of the raw gas entering into the plant. You've separated your lean gas, your ethane and methane. Now you have your propanes, you have your butanes, you have your pentanes, you have your hexanes that you need to separate. The next unit you use is your debutanizer. Debutanizer removes your propane and your butane, and that is your LPG. Dr. Riverson said this yesterday. Mr. Tando also said it yesterday. Ghana gas, our fraction for LPG is a mixture of both. But you will notice that in other temperate countries, the propane may be much higher, the butane may be much, the propane may be much lower, the butane may be much higher, and various different percentages being done around it. Okay, so we use the debutanizer to remove LPG. LPG, by Ghana Standard Board standard, and from what Albert has just discussed, LPG, we are looking at RIP vapor pressure because there's a standard in the country. The LPG that comes into your house, Ghana gas, whether it's coming from Ghana gas or whether it's coming from various different companies that import it into the country and sell it into the Ghanaian market, it has to meet the standards within the country. And our standard is true vapor pressure around about 7 point. No, true vapor pressure standard is around 9. But as a company, we are going lower than the standard. We're doing around 7.5 kilogram per centimeter cube for true vapor pressure. And I said it before, I remember I did my comparison of a class 6 beaker yesterday. If you were not here, a class 6 beaker, you heat it up and then you have salt and water, you heat it, you put a cork tube, and then you go, you condense, and then you will have water. Gradually, when you heat 100 degrees, you have steam. The steam will flow, and you have condensed water after your wet run. And what will be left is what? Salt, because salt probably has not got to its right latent heat to boil to be able to evaporate. So what is happening here is the same thing. We use in our distillation columns, using temperatures and pressure, and the temperatures are being generated by our heat medium system, a utility system which works with petrochem. And so petrochem is heated using some of the lean gas that we actually produce. We use it to heat the petrochem, and it's in a closed loop, just going around, finding the right boiler. This is a kettle reboiler, finding the right boiler, giving it the right temperature, setting it the right temperature and settings, going through your reflux ratio from your analysis from reading distillation columns, setting your reflux ratios well in order for you to have your pure products, which is your propane and butane in these circumstances. After you have your pure product, your heavier ends, which is your butane plus, it goes back and comes through the pentane stripper. Your LPG is cooled and goes through to your storage tanks for storage. Now your heavier ends. We talked yesterday, condensate. We need to stabilize this condensate. And condensate is most of the time butane plus downwards pentane and hexanes. So you want to stabilize it in order for you to be able to transport it, which is normally gasoline, which is picked up by thermal oil refinery, get to the right octane value. Albert has discussed already. Condensate octane value is ranging anywhere between 68 to 72 run value. So you want to get it to the run 91 in order for you to be able to sell it at gasoline. And that one is what thermal oil refinery does. So once we stabilize the condensate goes at the bottom and is then cooled and also stored in the condensate tanks. After that, then what is left is your storage tanks that you store the product in. This is very similar to what we've just discussed. I've just broken down everything into separate and discussed, but a whole flow chart of your pig receiver, gas entering into the plant, your yellow line, you go through your inlet separating unit 10, your inlet separating process, and your filter separation process. You dose glycol when you are not sure of the composition containing the water of the raw gas coming into the plant as a preventive measure. You go through your chilling processes, heat exchanger, your Joule-Thomson process, your low temperature separator in order to separate your liquid hydrocarbon, your gas hydrocarbon, your C1s and C2s, and in order to use absorption, glycol to absorb your water and for regeneration. And then you come to your fractionation, and then you come to your cooling of your products, which will go then to storage. We sell condensate to Quantum, and Quantum sells it into the market. We sell LPG, forgive me, to Quantum, and Quantum sells it to the market. We sell condensate to third parties by loading trucks, and then they send it to thermal oil refinery. The same way, compared to LPG, condensate specification is their density and then their rate vapor pressure. And you are looking at standards for Ghana gas being in and around 0.65 kilogram per centimeter cube for the rate vapor pressure. We talked so much about our utilities yesterday, and we've discussed a little bit about the utilities that are supporting the processing area. We talked just a few minutes ago about the glycol regeneration system as a support utility. We've we can also say about the instrument air and nitrogen system, which we discussed a lot yesterday. We talked about the heat medium system today already, going into the kettle reboilers, setting up the right temperatures and pressures for it, and our fuel gas, which is some of the gas. After it just finished the inlet separation process, we condition the gas, and that is used as fuel for our plants to run for power. One key thing that a lot of you may not be aware of is we have something we call the closed drain system. A closed drain system is any entrained hydrocarbons, liquids, that cannot, because when we go through our flare system and you want only gas being flared by going through a knockout system and clearing all any entrained liquids. The closed drain system is kind of a liquid waste that is stored very safely underneath the plant, the processing plant, actually buried on the ground. And as and when the tanks get filled, we are able to send trucks. Environmentally friendly, we work with various different waste companies, and then they come, we discharge it into their tanks, into their trucks, and they actually go and treat it. And for various it serves as also raw materials for various other small scale working companies. We treat our own waste, liquid waste, we treat our own solid waste. Our firefighting, we have firefighting monitors all around the plant. 26 monitors all around, dedicated around the plant, which is able to shoot water 9.5 bar gauge high. So it can shoot water to the top of the towers. And these towers are about 33 meters high. So it can shoot water. We can fight fire at any time. We have a dedicated fighting team 24/7. We generate our own power. We are able to cool our tanks. If these tanks that we have here, for any reason, the temperature, because of the temperate region that we are in, if these tanks, for example, the temperatures are really, really high, we have a cooling system, a cooling area filled with water, area, just a pit filled with water, just to cool the whole tank when required. And one key thing I would like us to take into consideration is, guys, this plant is designed in such a way that it is safety oriented, extremely safety oriented. We have a pressure relief valves. We have emergency shutdown valve. We have emergency shutdowns which will shut a unit of the plant down. Let's say unit 10. We have emergency shutdown which will shut the whole plant in. We have emergency full shutdown which will shut the whole plant and evacuate all the products out of it. And these are series of drills that as a company we go through. Mr. Yahaya tomorrow on the safety side will give you detail about the safety measures that are in place. There are detectors, gas detectors, infrared detectors, fire detectors all around the plant. If the level of the gas is higher in concentration, more than your LEL level is more than 5%, it will trigger a detector for the detector to cause that area of the unit to trip in order to safeguard the plant. This and say not just the plant, but safeguard first and foremost the personnel and then the plant. Our personnel are the most important thing for us, and subsequently, it is paramount that these safety measures are checked, they are calibrated according to the right standards that they have to. If it is 6 months, if it is 1 year, if it is 1 month, all the necessary calibrations are done in order for, and this plant is also monitored by teams like you, engineers going around, taking temperatures, pressures, and being able to monitor all those things. So this area is, or this slide is more or less the key utilities that we have run through and spoke of a lot already. A pictorial view again of the processing plant and the processing area, to be specific. These are our heat exchangers that you can see, our shell and tube heat exchangers that you can see there. And these are our storage tanks that we've discussed already. We store LPG in these spherical tanks, 2,000 meters cube each, and we store condensate in these cylindrical tanks, 500 meters cube each. We've already discussed this, but we'll reiterate on it as well. Raw gas coming into the plant. These are the key products. We have your sales gas or lean gas, depending on what you want to say. It forms almost 80%, 85% of the gas that comes into the plant. Your LPG, your pentanes, which we are still looking for market for, or a Marinos is already known, but it's not off taken, and that's why you have the short dashes. It's not fully fledged yet. And then we have the condensate, which third parties come in and pick it up. Quantum picks up LPG and sells it to the Ghanaian market. Quantum sells it to 8 out of the 16 regions, including Accra. And then we also have the sales gas. First, Ghana Gas's sales gas comes through. It is joined by the LPG sales gas coming from E&I, from Sansole. You have our 20-inch pipeline sending gas to our power producers, VRA, America Power, Twin City, and then to non-power producers such as Twyford, Wankan, and Jantal, and various other Marco Polo and various other companies that we sell lean gas to. Okay, so thank you very much. I think this is a very good summary of the processing and the operations side of Ghana Gas, and as a virtual tour gives you a vivid picture of what happens in the processing plant. Thank you.
Very, very interesting. Very interesting. Thank you so much, Michael and Albert, for the detailed lecture on the gas processing operations at Ghana Gas. It is time for questions, and like Michael said, we want it to be a bit interactive, so you can just unmute yourself, raise your hand, unmute yourself, and then you ask your questions. Contributions are welcome, suggestions are welcome on this particular lecture. These questions should go to both Michael and Albert. Both Michael and Albert. I'm not seeing any hands, but I think there is a question. Oh, the question is gone. Okay. Gideon Asante asking, please, the unit of
I think Gideon was trying to correct me on my unit, and thank you very much.
Okay. All right. That's good. Please, do we have questions? This is the time to ask questions. This is the time to ask for clarifications, etc. Oh, wow. Okay. Okay, there's a question here. What are the various percentages of these products and byproducts? I think that's what he's trying to say. What are the various percentages of these products and byproducts? Maybe we'll take this one. from someone.
Okay,
Thank
so I'm guessing there is more or less all the products what are the percentages? Is that correct? And the byproducts.
I am
Okay.
thinking so. But
Yeah.
Samuel, can you ask the question? Can you raise up your hand if it's okay for you? Okay.
Okay,
I
yeah,
think
he
has
said yes.
confirmed that.
Okay, yes, Samuel, yes. So you, as stated before, you're looking at lean gas of about 85%, depending. All these things are composition based. So as you wouldn't want to be specific in terms of that because it depends on your well composition, how much is processed actually also on the FPSO before it gets to you. But it's roughly you're looking about your lean gas being about 85% of your raw gas coming in, 85, 90% of your raw gas coming in, all depending on your composition of your wells. And sometimes, depending on which wells you are with, it can change.
All right. There's a question from Oscar. He's saying, what is the main difference between gas analyzer and gas chromatography? And does this exercise intend to engage new engineers at the end? Please tell us something about the flaring system. Are these instances where some takers complains about, I think he wants to say, about the quality of your lean gas? If yes, what do you do about it? We'll take these ones, responses to these ones, then I'll come back. Thank you.
Okay, so Albert, I'll take some of them and then I think you can come in with some of them as well, if that's okay.
That's fine, Mike.
Also, I'll start with the last one. It says, do our off-takers complain about the lean gas quality? So our main off-takers for lean gas, as we've already said, VRA and various different companies. But what we do as a company is, we stated it a few times with Albert and I. What we do is right from the beginning of processing, we know how much raw gas is coming in. We know what the composition is. So as much as possible, you would want to be able to process your gas to the right spec, because once you don't do that, there's no way there's no way to store lean gas. So you are able to, if it is water that is in it, you are dosing methanol right at the beginning. If it's glycol, you are dosing a high percentage of glycol. If it's temperature, so by the time it goes through those series, you would have been able to solve any problem. And the specification is also within a range. So more likely than not, we are always within the range. And we give ourselves very high standards. So we set our processes well, much higher, or in we have a higher specification internally than the specification which is given to our customers. So most of the time we meet the range. Okay, tell us something about the flare. Okay, good. So the flaring system, virtually, we explained it yesterday. We'll do that today as well. The flaring system is virtually where you want any entrained hydrocarbons in your processing area to be removed. I liken the example of us as a human being. We release waste through either going to the toilet, urinating, or sweating. So the same way, the gas processing plant, when you have temperatures and pressures and various, there will be energy is always transferred into something else. You don't have your full energy. So there will be a bit of hydrocarbon, a bit of entrained hydrocarbon in the system that will have to be removed. And the flare system, through its knockout drum processes, is able to drop any entrained liquid hydrocarbons into their knockout drum, wet at 1 atmospheric bar. And then it's only able to flare the pure hydrocarbon, entrained hydrocarbon. And when you flare, you are getting CO2 and water, because you are trying to always get a blue flame with the right fire triangle, with enough oxygen, with enough source of heat, and enough fuel source to have the fire triangle. Does this exercise intend to engage new engineers at the end? No, this exercise is an educational exercise. Thank you. Albert, do you want to take the gas chromatograph bit? Please,
yes,
sir,
Michael,
what is
I'll take that. I've been fortunate to get on the questions page. Now, that's an interesting question from Oscar. A gas analyzer and a gas chromatograph, they can be the same or can be very different, depending on the industry that you are in. Even within the gas processing plant, we can have a gas analyzer, which will not analyze the hydrocarbon makeup of the raw gas that we get, and also that of the sales gas or the LPG or the condensate. This gas analyzer will actually be a flue gas, which is a waste gas. So what components that it will be looking for will be something like carbon dioxide, carbon monoxide. So it has got different principles of operating. So using a gas analyzer is just a generic term. A gas analyzer within the, let's say, the car industry from a car exhaust will not be the same as that of a gas chromatograph. As I made a mention earlier in my submission, I did say that the gas chromatograph has been configured specifically for analyzing the type of gas that we are going to get from the FPSO and also those within the hydrocarbon sector according to the standards that I showed you earlier. So if you were to analyze for LPG, the standard for analysis to ensure that you know the hydrocarbon makeup has to be ASTM standard D2163. Now, if we were to analyze, let's say, the sales gas or the raw gas, and I have to use ASTM standards, it will not be this 2163 for the LPG, but in this case, it will be an ASTM D1945. So different products or feed has got different standards for its analysis. So I hope that it makes sense to you that a gas analyzer within here, let's say, if you went to the environment department and they made mention that they've got a gas analyzer there, it will surely not be a gas chromatograph. It will be an analyzer that they can use to, let's say, measure the hydrogen sulfide component present, or maybe the hydrogen sulfide component present in, if that is what they are looking for. I hope it answers your question.
Okay, thank you, Albert. There is more, so please, would you like to coordinate
okay.
it?
Michael, please, have you spoken about the flaring system?
Oh, I was hoping it will be coordinated and we'll answer that accordingly.
All right, so let me just quickly read the questions out. Then we can take it as it is. The next one says, please, what type of glycol solution is used for dehydration, and what is the ratio of propane to butane in the LPG? Okay. I didn't get the composition. Okay, let me read a series of them, then I will leave it and then you can take over, please.
All right.
All right, thank you so much. I didn't get the composition of LPG from Ghana Gas. Can you go over that part again? After the segregation of the raw gas, do we have bitumen at the end? Please, do you encounter transmission losses? If yes, by what percentage? Let me take this 2 in 1. I would like you to clarify this for me. You said the sales gas leaves at 50 bar. Please, do you do further compression? 2, please, how often is your CG calibrated, and is it done automatically or manually? Thank you. So we'll respond to these few ones, then I'll come back again. Thank you so much.
Okay, Michael, should I start? I'll take the glycol, I'll take the LPG composition, then I'll also take the raw gas and the bitumen one. I've managed to open the page, so
okay,
if
please
I
go,
take the
please
first,
go ahead. Please go ahead.
Okay, all right. The first one was to do from Bernard about the type of glycol that we use. Yes, there are different types of glycols that can be used. We've got the TEG, we've got the DEG, you've got the MEG. The MEG is what we use. That is monoethylene glycol 1. That is what we use. I know that offshore, they tend to use the TEG, the triethylene glycol. And some places in the dehydration system, they can use a combination of the DEG and the TEG, depending on how the configuration of the plant is. So in our case, in our plant, we use the monoethylene glycol. Thank you. Now, just to throw some little bit of light on the on the glycol. This glycol is actually in the temperate regions whereby where it snows. Like now that in Americas and the Europes where it snows, they put it as antifreeze. It goes into the antifreeze system and they spray it in front of their cars to clear the snow. So that is its basic property. So just a little add on. Now, the composition of the LPG from anonymous attendee, it's about, we are looking at, I will show the Michael, can you go to the composition of the LPG screen, please, under the lab side? Then I will show that. I can rattle it off my head, but I just felt. Okay, yeah. This page actually talks about the different components that ought to be present in. Normally, we don't have any methanol, methane in. We have very, very minute amount of negligible ethane as well in. That shows the efficiency of our plant, because we want methane and ethane to go to VRE or any of our lean gas off-takers as the sales gas. And afterwards, we get the propanes and the butanes, which is the ratio of almost 1-to-1. Some we are dealing with about 48% more to 48% more or 50. And then there's minor components of the C5+, that is the pentanes and the hexanes. So that is typically the LPG that we produce in the gas processing plant. Now, Mr. Blake posed the question, after segregation of the raw gas, do we have bitumen at the end? Okay, interesting question, but yesterday we made mention in our presentation, we made mention that we do not get crude oil. We deal solely with gas. And due to bitumen, it's in a different state. It's not in a gaseous state. So maybe you might think that there might be a particle, but it's got a higher molecular weight than all the C1s to the C5 to the C10s that we would expect. So we don't have any bitumen present in the gas that we receive onshore in the gas processing plant. However, this question will more be directed towards those on the FPSO, because they will be separating the gas from the crude oil. So, but in our plant, we do not receive any bitumen. So, Michael, do you want to take the transmission one and then
okay, sir.
Transmission losses?
Okay, sir. So for Samuel, transmission losses, I'm thinking you mean maybe the lean gas transferring through the pipeline or the processing. The processing side, you lose some water, you lose some impurities, and those ones are factored. And transmission in terms of the pipeline is more or less condensation within the pipeline, which normally when it gets to the various different stations, we use our filters to do it. But these are very, very negligible. And we won't be able to give you exact percentages. They are very, very negligible on that in terms of the pipeline. For Andrew, yes, I stated it goes at 50 bar. That's correct. Onto our pipeline and starts from our initial station. We also stated yesterday as well that when it leaves the processing plant, it goes to our Anoche compressor station. It's compressed from 50 bar up to around 80 bar, and then it joins with another 80 bar from ENI, and that's where it starts its journey, just not to Takoradi, but also reverse flow to Tema for power generation companies like SemPower, Sona Osogli, VRA, all in Tema. So yes, it's compressed again with our overhead, with our online compressors or our onshore compressors. Otherwise, if we don't compress it, then it goes to ENI if our systems are not, or maybe we have a maintenance process of it, it goes to ENI for compression to the pipeline pressure around 80 bar for it to flow through. Please, what do we calibrate? Yes, we do calibrations on our GCs. Albert, you can help me with that.
Let me take that, please, Michael. Now, as I made mention earlier, we have two different types of GCs. There is the one that is the tabletop one, which is used in the lab. And also we have the online GC, which analyzes the online GC every 3 minutes. It takes a sample and automatically analyzes it. Yes, so we've got a maintenance activity and calibration schedule for that. The one in the lab as well, we do manual calibration with it as well. So we've got a calibration gas of the right specification, gravimetrically weighted with all the different components, and we do the calibration to ensure that it's in line, or if it's off, then we make the necessary adjustment that is needed. Bear in mind that our products, we make money from our products, so we cannot give a product quality of a certain specification when we haven't done the calibration. So that is very, very key. We do the calibration of the gas chromatographs, and not just only the gas chromatograph, but basically almost every equipment that we have in-house, even our PSVs, pressure safety valves, and all that, they all get calibrated. So calibration is a very, very big, and our weigh bridge, for instance, that we use to weigh the condensate that we sell to the market. Calibration is very, very key for us. So we engage the standards authorities for the ones that we needed an external one to do, but the ones that we need that have to be done internally, we do have the expertise in-house to do it. So that is it. Then we move on to what does it? Please, does Ghana Gas sell some volume of the processed gas outside the country? No, we do not. Everything is consumed in country. Please, when do Ghana Gas normally do their piping and tank inspections to make sure that integrity of these tanks and pipes are intact? And are these inspections done by third party or by Ghana Gas? Now, with Ghana Gas, we do have an in-house QA/QC team and also an in-house asset integrity team. So they are responsible for the baseline analysis, and they've got their program for inspections as well, where they ought to bring in third parties to come and do it. They contact the third parties, which fortunately for us as a nation, we are very rich in that analysis and that inspection. So we engage third parties and they come in and work with our internal engineers for that analysis. So what I will do is that I will leave it to Mr. Coordinator to go ahead rather than jump the gun, please.
All right, thank you so much. Thank you so much. I believe maybe this will be the last set of questions. Then we will call it a day. Let me see what causes the losses? I think you've addressed that. Please, does Ghana sell some volumes? I think that one too you have done that. Please, when Ghana Gas normally do their piping and tank inspection to make sure the integrity of these tanks and pipes are intact, and are these inspections done by third party or by Ghana Gas? Can you elaborate more on the greenhouse gas emissions of your process? Very insightful presentation. What is the average density usually sent into the market from Ghana Gas, and how different is that from imported gas sold to the other 8 regions? I do hear that Atuabo gas has high pressures due to its propane percentage compared to the imported gas. What should consumers do differently to handle gas from your facility more safely? Do you make use of thermocouples and RTDs in your operations? Please, I learned from the one of this virtual tour that SGN doesn't raw gas to the US. So does that mean that the processed gas from SGN always conforms with Ghana Gas SOP? And in case of non-conformity, what does Ghana Gas do about it, since they are responsible for only transporting their products? I think these are a lot. Let's do a few responses and I'll come back. Thank you. Over to you, Albert and Michael.
Okay, Michael.
Yeah, Albert, you can go ahead.
Okay, should I go up with the first? Okay, the first question about the greenhouse gas emissions. It is very, very key. We do have an environmental team which monitors the greenhouse likely emissions. Inevitably, there is going to be emissions because we have a flare system. And when there's the occasional trip, in order to stabilize the plant, that means that we have to flare a certain quantum of gas. So we have got an environmental team which monitors, and every month they send reports to EPA because it was part of the reasons why EPA gave us license on the operation of the plant. So we are very, very keen about greenness within the company. Coincidentally, today's screen is actually about green, efficient use, sustainable use of energy. So greenhouse gas effect is very, very important to us. Now, Elon asked a question about the density of the gas as compared to that of the imported ones and where we sell to the 8 regions. Yes, it is true Atuabo gas has a higher pressure than that of the imported gas. Now, as both Michael and I have made mention earlier, our gas that we get is a raw gas. We process this raw gas, and after that, knowing the standards that is within Ghana, that is why we installed a debutanizer. So we didn't install the depropanizer and a debutanizer because what happens is that the gas that is imported into country, I think Dr. Riverson even made mention of it in his first submission, that the propane being lighter burns quicker, and the butane, by virtue of density, will burn slower. So when you are cooking, it will take a long time. When you are using more butane inclined gas, it will take longer for you to get your food sorted out. But when it comes to the propane one, it will burn quicker. So ours, because we are getting almost 1-to-1, which is, let's say, about 48 to 48 more percent of butane and propane, ours is the propane content being higher is going to create a higher pressure as compared to someone who is bringing in 70% of butane with, let's say, 28% of propane. Theirs will have a lower pressure than ours. So that is the reason why ours has got a higher pressure. And due to the makeup of the LPG, the hydrocarbon makeup contributes as a factor in its density. So if the butane is higher in ratio than that of the propane, the butane one will be heavier than that of the one that has got propane in. I hope that makes sense. About consumers to handle our gas, when we initially started the plant and we started producing LPG, what happened was that because we were getting sweet gas, and literally our LPG did not smell because the smell, the odor came from or has to come from mercaptan. In our case, there wasn't any mercaptan in. So people didn't know how to handle it. So what they ended up saying was that even though the absence of mercaptan is good because the sulfur will not lead to corrosion of your cylinders as well as even the tanks that and the cars that handle the LPG, even though it is good, but we need also a smell. So now we then later on had to go around with MP and other stakeholders to tell people, the users about our product. Now it has been fully accepted. However, now we inject mercaptan into the LPG for it to give it a smell in case of a leak. But the mercaptan has not got any heating value to your LPG. It doesn't add anything heat-wise, energy-wise. It doesn't add anything to it. It's only there for safety reasons, and safety is very, very key for us.
Okay. So, Albert, you want me to continue?
Yes, please. Then.
Okay, so just to add to the LPG side, so there is no safety concern in terms of the LPG. Per Ghana Standard Board, there is a set for your gas cylinders that it needs to meet. And once those pressure settings for your cylinders are met, our product is way lower than those specs. It looks like before our product came in, there was the specs were not being met well. So when that came, it became an issue. But we went through various sensitization all around the country, from north to south, and with the help of Ghana Standard Board, that was also done very well. So you wouldn't hear of it so many years now down the lane after 7-8 years of operating the plant. Do we use RTDs? Yes, we do. Our maintenance team and electrical team always have those equipments that are used. So yes, we do. Please, I learned from the one virtual tour that SGN, I'm guessing that's Sankofa or ENI. Yes, they do have, because they do meet our specifications. So exactly the same thing as explained before. When the ENI plant onshore, offshore, FPSO, is processing their natural gas or their lean gas, they make sure that it's within spec. And so before it will be joining our pipelines or before it will leave their pipelines from offshore, joining to our compressor, their compressor station, and joining our pipeline in meet specs. There is also gas chromatographs. There's also flow meters that will test the specifications before it joins into our pipeline. So we are all continuously in collaboration with each other, and the specs are always being met. Please, after production of LPG, what part of the process is mercaptan added? I think Albert has answered this. It's after you finish processing LPG, once it's in our tanks, when it's being sold, the BDC, which is Quantum, or is the one who would normally put in the mercaptans as we deliver it to their tanks. So they will normally put in the mercaptans as a ratio per standard by the Ghana Standard Board. Okay, I think we've answered all the questions that were given for now, so we can move on to the next set of questions.
All right. Thank you so much, Mike and Albert. I think you have done justice to. I will read out a few again. Ima is saying, please, after production of LPG, which part of the process is mercaptan added? And also, Elom is asking for both Michael and Albert's LinkedIn profiles so that they can connect and have a professional conversation about growth. Why is corrosion part of the LPG components? Is this not the reason cylinders corroded? Can you elaborate more on the greenhouse gas emissions of your process? I think we have done justice to that. Please, my last question. Do you at any instant adjust the wobble index of your sales gas? Wobble index, I meant. The last set of questions here. Please, what is the percentage of mercaptan injected into the LPG? Why is solid desiccants not used for the dehydration instead? I learned that it's more effective than glycol dehydration. I will allow Ishen Manasseh to ask his questions, then we'll add it to the ones I've read out, then we can proceed. Okay, his hand is down. I can't see his hands anymore. But if he still wants to ask questions, please raise up your hand again and talk. Thank you so much. Over to you, Albert and Michael.
Okay, so thank you very much. So if we start with the mercaptan bit, is Emmanuel. It says production of, yes, we do. I think I answered it as the last question. We do add it. It's normally, we don't add it as a company, but the vendor who sells LPG, which is Quantum Terminal with the BDCs, they add it. So once we send the product to them, they add it as part of their standards for Ghana or part of their specification for Ghana Standard Board. Are we part of LinkedIn? Yes, we are. If you Google my name, Michael Kwabena-Mriku, it should pop up. I don't have any such things hiding it away. Albert should be able to tell you exactly how his name is set up as well on LinkedIn, but we are all part of LinkedIn. I'll jump corrosion. I'll let Albert answer that. I mean to take off. Then emissions, Webby index, we do is we don't tweak it. Is our Webby index from the settings and specifications that you want to sell your sales gas in. You're looking around 50, 52 Webby index, and we're always within that range. That specifications that the lab team, Albert and team, are very, very conversant with as well. He will speak more to that. Please, do you plan on going into renewables? We're a gas processing plant at the moment. In terms of a company policy, it's something that company can decide on. At the moment, I can't speak for the company in terms of the renewable side at the moment. Okay. Albert.
Yes, Michael. Okay. I will pick about the question about the corrosion, right? Corrosion part of the LPG, which was not a corrosion part of the LPG. Okay, now, as we have answered this earlier, but it seems there was I'll throw more light on it. LPG normally has got a DNA of its source. We are getting LPG from a sweet gas, so we don't have corrosive components present in. So we don't normally have, or we have negligible sulfur components present in. LPG that can be produced from a crude source will normally have those sulfur compounds present in. So if, let's say, it was to do it, thermal oil refinery was to produce LPG, it wouldn't inject mercaptan into it. Certain places, the crude source will have such a high sulfur containing compounds in that they will have to remove some of the sulfur containing compounds so that it fits in within a certain specification. In our case, our LPG, there isn't, but Ghana Standards, NPN, Ghana Standards Authority, whether it's present in or not, they want you to disclose it. So we have to do the analysis for corrosion and put the results out there. There is a certain maximum cap that it can go to, even with the injection of mercaptan. There's a certain maximum cap, because if there is so much in, over time, it will lead to corrosion of the valves, of the cylinders, and the hoses and all that. So it is important that the corrosion part, whether it's present or not, is also captured in the LPG, because the cylinder obviously only contains the content of the LPG. So if the cylinder, in inverted commas, most of the time is going to corrode, excluding the environment that it's in, it will be the content of the cylinder. So we have to prove that this was the content of the corrosive properties that was within the LPG. So I think that was it. That, I guess, answers the percentage of mercaptan injected in as well. So, Mr. Coordinator.
So I think the percentage should be around 4 ppm.
So much. At a point, I lost you. I don't know if it's my network. So far, so good. We don't have any more questions on the chats and even the Q&A session of the webinar. And there are no hands up here. So we'll assume there are no more questions. As Michael and Albert has declared, they are on LinkedIn. So any further question you want to throw to them, kindly connect with them on LinkedIn and let's take the conversation from there. I would like to thank everybody on this call for spending some time today to listen to the lectures of gas processing plant operations at Ghana Gas. On behalf of SPE, I would like to send special appreciations to our lecturers, Mr. Albert Mensah-Tando and Engineer Michael Kwabena-Muriku, for spending 2 days with us, trying to make sure we understand how gas processing plants operate in here in Ghana. The conversation continues tomorrow. Tomorrow's conversation will be very interesting. We'll look at health and safety measures looking at health and safety for the Ghana gas sector. And then we'll look at gas tariffs and pricing. This will be done by Mr. Yaya and then Sylvester. These are the people who will be having tomorrow. Tomorrow, our moderator will be James Alote. Our moderator for tomorrow will be James Alote. And we are expecting the CEO of Ghana Gas to pass through and give us a word. The CEO of Ghana Gas to pass through and give us a word. So thank you all so much for attending. I expect to see everyone on the call tomorrow for us to end this virtual internship and field trip successfully. Thank you so much. Thank you.
Thank you very much as well.
Okay, thank you.